Hello, good evening. Now we are in Module Care Paper 1 Set 7. We will start with discussing in Quadratic Function Chapter 3, one of the topics that the students consider is quite difficult. Okay, let's see here. What are the things that is required from you in this question? You must be able to know exactly three things. There is minimum or maximum value, minimum or maximum point, and you also have to know the equation of axis of symmetry. In this case here, there's not much calculation needed, but you have to find and you have to know the connection between the function given and the function in the diagram. Okay, let's see here. If you look at the given function here, okay, there are two things that we can derive here. The first thing is that the value of q here, the value of q is considered the minimum value. So when you say it's a minimum value, it represents the value of y coordinate, the minimum value of y. So when you look at the diagram, the minimum value of y is at the minimum point. The value of y here is 3. So, well, it's such an easy question here. By understanding or connecting between q and 3 here, because 3 represents the minimum value of y, q also represents the minimum value of y. So, in this case, the question for q is 3. And then we're looking at the value of p. When you look at the value of p here, it's p here, there must be a connection between p and x. And x is obviously the value of x in the minimum point, that is 2. If the value of x in the minimum point is 2, so p must be negative 2. So p must be negative 2. Or if you are still unsure why p is negative 2, we can do like this. X plus p should always be 0. X in the diagram here is the minimum. At the minimum point, the value is 2. 2 plus p is 0. P is negative 2. So the answer P is negative 2. Okay, now what's left here? Oh, we haven't calculated the value of A. So before we can calculate the value of A, we can substitute all the values that we have calculated here. So y equal A x minus 2 plus 3. Okay, now we have to choose one of the coordinate given in the question that is on the curve, but please do not choose the minimum point or the maximum point, because if you choose the maximum or minimum point, the value of x will give you 0. So now we choose 0, 5 here. So 5 is coordinate y, A, and the value of x is 0 minus 2 squared plus 3. So 5 equals 4a plus 3. 4a is 2. A is 1 over 2. So this is all the answer for question number 1. Now we are moving fast to quadratic function also, and here is a different kind of question where you have to do the completing the square method before we can actually answer the question. So another weaknesses here for my students is they are unable to complete the square. So here there are several methods that you can use here, but the most important thing, you must not get panic, because when you look at this, if you follow the textbook formula, you have to know that this is going to be plus 7 over 2 squared minus 7 over 2 squared plus b. And all we have to do is to choose the square, the perfect square here, and form x minus 7 over 2 square minus 49 over 4 plus b. Okay, then again, just like question number 1 just now, you have to know there are two things you need to remember. You have to know the minimum value and you have to know the equation of axis of symmetry. In this case, in the question, they say that the minimum value is 1 over 4 and in our completing the square, we have this is also considered as minimum value. So what do we have to do here? We have to equate. We have to equate it. So we can see here that negative 49 over 4 plus b is 1 over 4. B is 1 over 4 plus 49 over 4. So it's going to be 50 over 4. B is 25 over 2. That's all for question number 2. Now we are going to go to questions that is in topic coordinate geometry. Again, another weaknesses here that I can see from my student is that students tend to rearrange this into y equal mx plus c, whereas they don't need to do that because it is obviously here that 5 represents x-intercept and negative p represents y-intercept. So why should you go to the extent of trying to rearrange it into becoming y equal mx plus c just to get m, where you can just get your m straight away in the question? So here we know that m gradient is not only y1 minus y over x1 minus y, x, it can be also be m equal to negative y-intercept over y-intercept. So in this case, we'll have to do this. For the first equation here, it's so easy. The m1 here is going to be negative y-intercept. In this case, the y-intercept is negative p over 5. Okay, and your m2 here, there is another trick that I can teach my student, but it takes a lot of exercise or effort to do this. I will circle 10 and I will circle 12. In this case, I will say that I will assume that 10 is the y-intercept and y12 here is the x-intercept. So if I assume that way, it should be negative 10 over 12. But if you are so unsure about it, I would advise you to do it in terms of y equal mx plus c. In this case, 12y equals to negative 10x plus 3, y equal to negative 10 over 12x plus 3 over 12. And y is actually negative 5 over 6 x plus 3 over 12. So here, negative 5 over 6 here. Now, see, you can see that negative 5 over 6 here is also, this is negative 5 over 6. But remember, the word perpendicular here means that m1 times m2 should be equal to negative 1. So in this case here, let's have round here. M1 is P over 5 times negative 5 over 6 is negative 1. So we eliminate this, it's going to be negative P equal to negative 6. P is 6. Okay, that's all for this session in paper 1 set 7. Question number 1 until question number 3.